By infinite series, I'm talking about sequence of numbers, A1, A2, A3, but then you add them. And it's an infinite sequence, so the addition doesn't stop. Such a thing is called an infinite series. So when you say series, it differs from the word sequence, because sequence are just numbers themselves. Series is when you add them. That's what series means. If you have an infinite series like this, you can rewrite this as a summation of n from 1 through infinity of an. So oftentimes, the infinite series will be presented in this form, with an given as an explicit function of n. Now, this is a very informal way of defining what an infinite series is. There is a more technical and mathematically correct definition of an infinite series, and it's like this. The definition of n from 1 through infinity of an is that it's the limit of the so-called partial sum. So you add from a1 through a capital N, and because you're stopping at a finite sum, that's called a partial sum. And then you take n to infinity. That's the definition of this infinite sum. This definition seems just natural and obvious, and you will understand why I'm actually writing that out. But after a few examples, there will be times when this definition will become important. So hopefully I can show you that example later. Okay, there will be two kinds of infinite series that we are going to do today. And these are both important. One would be geometric series. And another one will be telescoping series. But there are many more infinite series, in fact much more infinite series than these two types. But these two examples will be a good way to understand what an infinite series would be able to do by looking at these as examples. Okay? So first of all, let's talk about geometric series. Geometric series.